All right, so today we are working on slope, we're going to be talking about the rise and the run. And the essential question is, how do you calculate slope? And I represent the slope by a letter because I'm so lazy. I don't want to keep writing it over and over again. So I represent the slope by the letter M. Now, the reason why I use the letter M is the person who first defined the slope was French, and he thought of slope as meaning mountain. Okay, so like a mountain slope. All right, and that's the reason why we use the letter M for slope instead of the letter S for slope. So M means slope because of a mountain slope. All right, so I have here a video that's a mnemonic, so this should help you remember slope.
Slope is the rise over the road, distance up or down, divided by the distance side to side. Slope is the rise over the road, distance up or down, divided by the distance side to side. As the line moves from left to right, positive slopes go up, negative slopes go down. Y2 minus Y1 goes in the numerator, X2 minus X1 in the denominator. Slope.
All right, so let's make some calculations. We need to write all that stuff down because that was all good definitions. All right, so slope, that's what we're going to be defining. I have here a penguin that's going up a slope. Slope is the, okay, so what we're defining is the slope. So slope, slope is the rise over the run. And when I say over, I mean divided by. So I mean the rise divided by the run. And the letter that I'm using for slope here is M. Okay, so slope is the rise over the run. It's also, we need to define rise and run. So rise is the distance up or down divided by the distance side to side. And that makes sense because the sun rises. Okay, so when you rise, it's up or down. And then when you run side to side. Okay, so if I wanted to abbreviate that, I would say the distance up or down is the rise, and it goes up or down, and the distance side to side, well, that's the run, it goes side to side. And we're going to be dividing the rise by the run. All right, so let's practice that. I have here a graph, and I picked a couple of points on the graph. I picked this point and this point. Now, I could have picked any other points. I could have picked like this point right here. That would be a really bad point to pick because it's not exactly on a grid points. Because I don't want any decimals or fractions, all the points that I pick are going to be on a grid point. So let's look for another point that would be, that's a good one, and look here. The line is on a grid point right there, so that would be another good point. I didn't happen to select it, but I could have. Okay, so the 2 points that I selected were here, and I'm going to be making a calculation by finding the rise, that's the distance up or down, and the run, distance left to right. Now when I say left to right, I mean start on the left, start on this side, and go to the right. So go from the left to the right, that means this is the point that I start with. So let's find the distance up or down in this triangle right here. Up, 1, 2. So the distance up or down is 2. And then I need to know the distance left to right. So that's 1, 2, 3. So the distance left to right is 3. Now, the slope is the rise over the run. So that's 2 over 3. All right, now I've got another example here. So another point that I could have picked, well, I could have picked this point right here, and that would have been just fine. Or I could have picked this point right here. Actually, I could have picked any of these points, and I would have gotten the same slope, but it's easier to pick points that are on a line because this would be 2, right? I wouldn't want to pick 1.5 right here. I'd want to pick the one that was on 2 because that's easier to subtract. Okay, so I've got a couple of points here, and here, and I need the rise this way, and I need the distance left to right from the left to the right, and that's going to be the run. All right, so let's calculate those two things. So up or down, 1, 2, 3, 4, 5, 6. So the distance up is 6. And then the distance left to right, that's pretty obviously 1, 2, 2. Okay, and then the slope, I have to divide those things. The slope is the rise, that's the 6, up 6, over the run, sideways 2. So that's 6 over 2. Now in the last case we couldn't simplify that fraction, but 6 over 2, 6 divided by 2 is pretty obviously 3. So I can simplify 6 divided by 2 is 3. So the solution for the slope is 3. And I've got one more example here, and this is different than the other two in some way. So let's look at how what the other two looked like. Okay, so this one from left to right, starting here and going this way, was going up. This one from left to right, starting from left and going right, was going up. This one from left to right, starting from left and going right, is going down. So this slope is going down, and that means the slope has to be negative. All right, so when we're calculating our distance up or down, this time I'm going down, and that means I'm going to have a negative slope to go down. So I've got 1, 2, 3 going down to the negatives instead of up to the positives. Okay, so that's a negative slope going down, negative 1, 2, 3. And then the distance left to right, I always go from left to right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The distance between those points is 5. And then the slope is the rise over the run, so that's negative 3 divided by 5. Now I cannot simplify that because 3 does not go into 5. Slope. Let's remind ourselves what the definition was. So here I have the slope of a rooftop. It's the rise over the run. The distance up or down divided by the distance side to side. Okay, and then there were some more lyrics after that we need to define. So let's get on to those. As the line moves from left to right, positive slopes go up, negative slopes go down. Okay, I'm going to repeat that from the beginning. Okay, so please write down, make your paper look just like this. So at the top of your paper, as the line moves from, and then at the bottom, left to right, and you need to leave yourself room in the middle to draw this graph. Positive slopes go up, and at the top it needs to say positive slopes go up, and then you need to sketch a graph that goes up. Pretty simple, I don't want you to make it exact, just an axis here, and then a line that goes up. Okay. As a line moves from left to right, positive slopes go up, negative slopes go down. I'll use the highlighter this time so it's a little bit easier. So you need an axis here, and then you need a line that's going down instead of up, and you need to say negative slopes go down. So you have one line here that's an example of positive slopes going up. And then you've got another line here that's an example of negative slopes going down. Okay, so after that, what does the song say? The song has some kind of a formula, right? It says y2 minus y1 goes in the numerator, and x2 minus x1 goes in the denominator. So if you would please, I'd like you to write that definition. So this obviously must be the rise, another way of defining the rise. And this rise over, this must be another way of defining the run. y2 minus y1 goes in the numerator, and x2 minus x1 goes in the denominator. All right, and I'm going to break this off to a second video so that we can make some calculations with this.